If I come into animal things, I can't think of a clever name for this right now. All right, so if I come into this and I say var zoo display is equal to new zoo display, I'm going to get a zoo display full of a bunch of monkeys named George. I think it's fair. Let's say that for whatever reason, I have a monkey of my own. So let's just say a new key equals GUID dot new GUID. And I say var monkey. Let's make it a panda. Let's put a panda in with all the monkeys. Paul. All right, so I've got a panda. I know what this panda is. I've got his tag, right? I've got his zoo display, and I'm going to take that panda and animals dot add panda. Right? This is what I want to do. So what you'll see here is, oh, sorry. There we go. So because my list of animals are just that contract of iAnimal, I can stuff it with whatever animals I want. So I've stuck this panda inside of this zoo display with all these monkeys. And now I want to get my panda back, right? So say panda Paul is equal to zoo display dot get animal key. All right. So first thing you're going to notice is it's going to complain because I can't actually get back panda because without getting too far into the, covariance and contravariance, this is by all rights, as we defined it, a list of iAnimals. So while I can't get panda back, let's just pretend I go up to this monkey cage. They're all super intelligent, and I say, "Could I have my panda?" And they're like, "Dude, there are only animals in here. Please be more specific." So I get back Paul. And the only way I know it's Paul is I say, "Paul, would you please speak?" I mean, I know I got you back based on the key, so I'm reasonably certain. But just to prove out the magic trick, speak. Because monkeys only say ooh, ooh, ah, ah. And pandas say tally ho. All right. So, what this allows us to do is we can take a list or a collection of things, presumably a big list, and we can put it aside in memory. And then whenever we need something from it, we can ask for it by reference, essentially. So since we're putting it in a dictionary, we can say, "Could I please have the thing that is associated with this ID?" And it'll give it back to us. And then we know what that thing is, and we can do whatever we want with it. This is going to be more effective than either fetching things from the database every time and doing a round trip, or newing up objects every time. Because again, the problem space here is that we've got a finite amount of memory, and we want to know what we're working with at any given time. So if we only had space and memory for 10,000 objects and a little bit of swap space so we can do some fun things on the side, we want to load up all of our assets first and make sure we're not going to run into any problems later on. It's a pretty simplified version of it, but when we start looking at our game later, That's a great example of it because in a game you're going to have all these assets. And it takes time. And nowhere's that more apparent than in a game where you're like, man, it takes time to load up assets. And if I wait until I need an asset to load it, it's going to slow down the action, the frame rate. It's going to gump the works. What I want to do is front load all those things, get them into memory, and then when I need them, they're right there for me. So that's the flyweight pattern. And here we demonstrate that by, we've got this closet, right? This is closet full of stuff, and all we're saying is, I don't even care what's in there. It doesn't matter to me. But when I need something, I need it immediately. And in this case, we shoved a panda in there, and then for whatever reason, we needed the panda back out right away. So let's go and start this. All right. So nothing broke. If we look at our zoo display, we've got 6 animals in there, each with their own key. Now, if we look at the value, we can see we've got 1 panda in there with the key that we gave it. So we ask for that guy back, and then we ask it to speak, and then we say panda key goes tally ho. So I wish it was more complicated than that, but honestly, if you've been here for the last 5 weeks, this is one of the simpler, I don't say simpler, this is one of the patterns with the fewest moving parts. I'll say that. Because it is, it's a concept, you got to grasp it, it's going to take some effort, so I don't want to call it simple when it's really not, but because what makes it kind of a more advanced pattern is there's so much flexibility in how we implement it. And when we look at our game here in a second, once I check this or commit this back to GitHub, we'll see that we've already done it a few places. So there's got to be a little bit of wisdom and know-how in evaluating where do I use it, why do I use it, and am I really getting the benefits from it that I need. All right, so wire it all up. Let's go ahead and commit. Okay, so let me go ahead and close that down. Now let's jump into our MUD-Z game and see where we're already taking advantage of this. In previous weeks, it arises naturally. The waiting eyes. Hello, the waiting eyes. Okay, so we're back inside our game now. We're inside the main method, and things are looking really clean for the most part. Let's see, we're using our command pattern to execute things. Last week we decided we're going to beat Gary to death. So essentially, we ask Gary to heal Beth. Then Gary immediately tries to fight her. Beth doesn't like this, so she responds by beating Gary to death. So still some more work there, but we're going to take a look at our implementation of the flyweight pattern. So if memory serves, inside of player, player factory. So here's a great example. When we have a player factory, that guy, and we're creating a new player, we take in a name, a gender type, and a player type, and then to create a new player, we need to give it a strategy, a class strategy. So it's either going to be a carpenter or a army vet or a politician. And so instead of newing that up for every character, so if we had 10,000 players in the game, they'd all have 10,000 associated objects. We go ahead and we create a dictionary, a player strategy map. So no matter how many players we have in the game, we'll only ever have 5 instances of the player strategies. And so you can imagine if you were able to do this for various aspects of your class, then you'd have exponential savings, right? So this is a very light example, but if every player also needed access to some other repository of objects, and there was 500 or 1,000 things inside of that, you wouldn't want every player to carry around 5,000 instances of whatever thing you want to refer to. You'd rather have one central resource that everyone draws from. The Waiting Eyes asks, what is going on? Not much, The Waiting Eyes. We are in week 6. It's hard to believe. Week 6 of going over design patterns and applying them to this game. It is crazy. Okay, so that's one example in the game where we're already using this. And it's a good example because I think there's some places where we can implement this and it's going to look a little bit different. But this is an often overlooked way to optimize an application to be more efficient of its memory usage, is by saying, okay, how much weight is each one of these things carrying around, and what can really be shared? And that's where the flyweight pattern comes in. So, if we look at our game objects, when we want to grab something from the game objects, we're going by the name, which is fine, but if we apply the flyweight pattern, let's go into HiveMind. So we're creating our world, which is a grid, and has rooms and a sheet. Each room has a room key and content. We've done a lot over the last 6 weeks, so if some of this looks foreign, run back and you can see us build all of this from the ground up, one class at a time. Okay, so then down here is where, because we don't really have a database yet, we don't have anything out there, so we just go ahead and we say, hey, for tests and giggles, let's just add all these objects to a list of game objects. So we want to turn these game objects, sorry, scrolling pretty quickly. We want to change the game objects inside of a room let's go over here to our environment. Yes. So here inside of our room content, every room in our game has a location on our map, has a title, a description, and a list of game objects. This is fine, but if we wanted to really conform to the flyweight pattern, we'd give this a key. So we'd make this a dictionary, and then we'd find the objects by that ID. So let's go ahead and see if that has a place in our world. The Waiting Eye says, can you show us what the game looks like so far? I absolutely can, and I'll step through it. So we're making this zombie survival game that's an homage to old school text role-playing games. So it's all text-based, it's all kind of, read and use your imagination, and everything that we do pulls inspiration from the old Major Mud, Telenet, Trade Wars, BBS days. So, we create our HiveMind, which is our game engine, which seeds in our